Hello everyone, thanks for joining another NCL Live. I'm Franz with Skyline, and we host the National Cyber League competition. We run these episodes for you, so please stick to the end to vote for the poll, in the poll for our next topic. This week's topic is going to be running an Nmap scan, and so let's just jump straight into it. So let's cover very briefly what Nmap is. Nmap, simply put, is just an open source port scanning tool. And it's available default on Kali, which makes it very easy to get access to if you have Kali installed. And it's also kind of like the de facto command line tool that you would use for port scanning. You can use Nmap for a couple of different things: to identify what devices are on a network, to identify what services those are running on those devices. You can use it to figure out operating systems, as well as to identify like firewall or network filters that might be in place. If you're not familiar with what ports are, let's just do a little bit of a debrief here, a little bit of an intro. Ports are, you can imagine them as mailboxes for computer networking. And so if you want to communicate with someone via the mail, you will package your data, your information into a letter. You'll put it in the mailbox, and it'll go from your mailbox and be delivered via the magic of the internet to your destination's inbox, right? And the way that this works for computers is that data is stored into capsules called packets. A packet is just like a chunk of data that is being sent over the internet. And those packets are being sent from one computer to another computer for a specific port. And the port is like a mailbox. And so imagine a computer as an apartment complex. You may have multiple different residents in the apartment. And so you need to get the data to the correct mailbox. And so different applications on each computer listen for traffic on these specific ports. So as a translation, these applications are basically checking the mail. If you're running a web server, that web server is listening to a port on your computer, and it is checking the mail, is checking for any packets that are coming in on that port. Now, another thing to note is that there are two very common protocols being used on the internet for communication: TCP and UDP. They both use the same numbering system for ports. And so it's very important to realize that when someone's giving you a port number, you need to know whether they're referring to a TCP port or a UDP port. Most internet traffic uses TCP, but some does use UDP. And this is based upon the decision of the person who created the software application. And so TCP provides a lot more reliable connections, is used for majority of internet traffic, but UDP is still very commonly used. It's much faster but less reliable. And so you will see TCP for any HTTP traffic, any HTTPS traffic that you encounter. UDP, you'll see that. I think the most common use case is DNS traffic. It really depends on the application and the different protocols that are being used. Some protocols could use both TCP or UDP. And so when someone's giving you that number, the port number, you should find out whether they mean UDP or TCP. Generally, like, there are very common applications that use standardized ports. And so, for example, if someone says, port 80 is a very common port for TCP traffic for the HTTPS protocol, the HTTP protocol. And so if you're running a web server with HTTP, you're probably running it on TCP port 80. I have some examples here for TCP port 80 for HTTP, TCP port 443 for HTTPS, and these are considered well-known ports. Basically, the community has decided that, hey, so we don't have to guess which port to connect to on each computer. We're going to standardize things as much as possible. And we're going to say that generally, if you're running an HTTP server, you should run it on port TCP 80. And if you're running an HTTPS server, you should run it on port 443. There's a giant Wikipedia list. If you Google Wikipedia common ports or common TCP ports, you will get a giant list that says, hey, typically this traffic is on this port and this traffic is on another port. The thing to keep in mind is that you can technically run any application on any valid port. The fact that HTTP typically runs on port 80 is more of like a community standard thing rather than any technical limitation. There's nothing that stops you from running an HTTP server on a different port. That's the choice of the person that's running the server. But if you are running a HTTP server and you want other people to connect to it on the internet, and people are trying to connect via the web browser is going to assume that it is HTTP port 80. And so if you're running it on just as an example, port 81, and someone tries to go to your website and they don't know that you're specifically using port 81, their browser is going to assume that it's on port 80. It's going to guess it. It's going to try to connect to port 80, and then it's not going to work. And so this is why there's kind of these generally community standardized port numbers, just so that we're not in this guessing game trying to figure out what port is this application running on. It's hard enough trying to figure out what the IP address is of the device that you need to connect to. We don't need to add the additional difficulty of trying to guess the port. Now, some organizations will try to use non-standard port numbers as a way of like hiding applications or obscuring themselves. It's security by obscurity. It's not recommended because if someone does something like run a port scan, they can identify that. And so just keep in mind that there are these standard ports, but nothing stopping people from running applications on different non-standard ports. Another thing to keep in mind is that if I'm sending a letter, there is a source and a destination, right? You write at the top of your letter, this is who I am, this is my address. And if you are in an apartment, you write your unit number. If you're sending mail to someone who's in another apartment with a unit number, you're writing their information, their address, their unit number. Just like there's a unit number for the recipient and a unit number for the sender, it's the same thing with ports. When internet traffic is happening on TCP or UDP, there will be a port for the sender and a port for the recipient. And this basically allows for when you go and you connect to a website, let's just say the website's running on port 80, TCP port 80, you're connecting to TCP port 80, the server needs to know, where do I send my traffic back to, right? If you're coming to me and asking to request a website, where do I send that data back to? And that's why you need to specify your IP address and you need to specify your port. Because if you only specify the IP address, then when the server sends the data back and it sends it on the wrong port, your browser isn't listening for traffic on that port. And so the data will come back, no one will check the mail, so to speak, and the data will be lost. And so when you connect via your browser to a website, behind the scenes, the web browser is actually opening up an ephemeral port. It's a temporary port on your computer, and we'll be able to see that when we go through our demo today. And when that is happening, any data that comes back from the server will reach that ephemeral port because your browser will include that in the communication, and your browser will be able to read that data when it comes back from the server. So just keep in mind that servers typically listen on standard ports, but when you connect as a client to the server, your computer, your device needs to open up an ephemeral port in order to receive any correspondence back. If you want to learn more about networking, if this stuff didn't quite make sense, I'd recommend you check out this link at the bottom, trove.cyberskyline.com. That's where we are hosting our written resources to help people learn. We have a section in our Computer Fundamentals for Cybersecurity collection for networking, and it will explain a little bit more about ports. It'll actually go into further detail about TCP, UDP, how does internet networking work in general, and I'd highly recommend you check that out if you want to learn more. So now that we know what ports are, we need to understand what different states that ports can be in. What are the results that we'll see from our Nmap scan? Nmap is going to search for open ports. It's going to see what's available. And so we need to know how to interpret those results. There are three standard results that you'll get back in Nmap. There are more than just these three, but I'm just going to cover these three to begin with. There's open, which means that there's an application actively listening for connections at this port. That basically means an application is checking the mail. There's closed, which means that the mail the port is accessible, but there's no application listening on the port. That means the mail is being delivered, but no one is checking the mail. There's no application going through and reading that data. There's also the third state, which is filtered. And that means that Nmap cannot determine if the port is opened because it's of blocking from a firewall or from a network device. And so basically it means that from where you are sending the traffic, you are being rejected. So if you send your mail in a little envelope in the mail system, it's getting being dropped in the mail. Maybe we don't have a good analogy for this in the mail system, but in a corporate environment or any security environment, you might say put up a firewall that says, hey, I don't want to accept any traffic coming into my network on these ports or from these IP addresses. Maybe you need to be on the local network in order to send mail, to send data to that server. So you don't get information about what is causing the blocking. It could be a router that has a firewall on it that is blocking the traffic. It could be a firewall software running on the server itself or on the device itself. You don't know where that blocking is coming from. And you don't know how you might be able to get around that blocking unless you do more investigation. It could be that you're being blocked because all traffic is being rejected for that port. It could be because you're being blocked because you're not in my local network. You're over the internet. You're not sending this traffic from my building, for example, and so I'm blocking you. If you were doing this same request from within my local network, from within my building, then maybe the network traffic would go through. But you can't really tell that unless you do additional scans, additional research into why that traffic is being blocked. There are also results that you'll get back from Nmap, which are a combination of multiple of these states. So you might, for example, get an open pipe, like open or filtered. And that basically means that Nmap thinks that either it is open or it's being filtered, but it's not sure. And so you might have like a combination of these two things happening, or these three things happening. Some other tools that we're going to go into and show today are Nmap and IP tables. NetStat and IP tables. NetStat is a very useful utility in Linux, which will actually give you information about your network connections. And we're going to do that. We're going to use that so that you can see what ports are supposed to be running and then how that compares when we run the Nmap scan. There's also IP tables, which is a host-based firewall. And so on our machine, I'm going to run IP tables. I'm going to block traffic. And so you can see that will change the Nmap results now that the firewall is blocking traffic. And so that's just going to be for demonstration purposes there. I'm going to quickly check the chat right now. I wanted to make sure I get all the introduction at the beginning. I'm going to check some questions in the chat. And then after that, I'll jump into the demo. Oh, looks like there are no questions in the chat. All right. If you have any questions, please ask in the chat. I'm going to go jump into the demo, and when I get to certain breaking points, I'm going to go through the chat and answer people's questions. Okay, so right now I've switched to my Kali machine. Logging in. And we've got our terminal here. So what I want to do first is demonstrate setting up a test server on my computer here, my local computer, this Kali machine. We're going to set up a server on the Kali machine and scan ourselves and see what we get. And so the first thing I want to do is type in netstat, and then I memorized this combination. I don't honestly remember what these different options specify, but I just remember it as netstat plant. And netstat plant will display all of your open ports, all of your open TCP ports on your device. And you can actually see that right now, I have some traffic here. This is for my browser. I actually have my browser over here. It looks like there's 2 connections open for my browser. This is my local IP address here, and the ephemeral port, which is going to listen to responses from that web server. And you can see here that this is the IP address of this cyberskyline.com web server. So one of our web servers on Cyber Skyline has this IP address, and actually there's a second one here. Maybe this isn't. Maybe there's connections for something else. Maybe this isn't a Cyber Skyline server. Maybe it's something else. Maybe I'm connected to 2 different Cyber Skyline servers. I have to look this up more to find out. But the basics here are that I have 2 active connections with 2 different machines running on TCP port 443. And if I actually go and I do a Google search, TCP port 443, you can see in the Wikipedia list that 443 over here, Hypertext Transfer Protocol HTTP, secure HTTPS. And so that is this here, my HTTPS connection in my browser. I can see it when I run netstat. And you can actually see that in my Google search there, I open up a ton of additional connections to all these different servers. You'll also be able to see the state here. And the state will tell you whether you're establishing the connection, whether a connection has been established. This time wait indicates that the connection is being closed. And some of these will go away if I run this again in a little bit. There's like a timeout period, so you actually have to wait for a little bit before you know that it's closed and it's gone. And if I check back later, I think some of these will disappear. And I definitely, if I close my browser, now they're all in time wait. And so give it a little bit of time. The operating system will wait a little bit to make sure that it's actually closed, and then they'll clear out from this table. But what we want to do here is I'm going to go into my test folder here, and I have a file called hello.txt, and you can see there hello. That's the contents of my folder. And what I want to do is I want to have my own web server. I'm going to start up my own HTTP web server. And there's a very, very convenient way to be able to do this without like installing anything crazy. If you have a Kali Linux machine, you should have Python 3, and Python 3 has this thing called the mini HTTP server, which will allow you to basically spin up an HTTP server that will display and serve up the contents of a directory. And so what I'm going to do is I'm going to start that. The command is python3-m http.server, and then I get to specify the port number. Now, I want to put it on port 80. If I hit enter, I'm not actually sure if that worked, because port 80 typically requires special admin permissions, root permissions to be able to access. But I don't know, maybe I somehow was able to do it without any issue. But you can see here that what I did is I ran the curl command. The curl command is going to make a request for a HTTP or HTTPS server, and it's going to show me the response that I get back. This IP address here, 127.0.0.1, this is referred to as the loopback address. This is the IP address referring to the computer that I am on. So this refers to yourself. You can also use the host name localhost, and it refers to the same thing. And this is very convenient if you want to specifically connect to a web server or some sort of server that's running on your own computer, because the IP address will not change. It's always going to be localhost. It's always going to be 127.0.0.1, no matter what device you're on. So that's very convenient. And you can see here that when I run curl, I get the response back. This is HTML code, and I can see it says directory listing 4 and then hello.txt. Now this doesn't display very pretty because it's just the raw HTML code. It's not being rendered in a browser. If I wanted to go and do that, I could come in here and I can type in localhost, and there's my hello.txt. This right here is corresponding to this HTML code, right? Directory listing 4 / directory listing 4 hello.txt. That's this. So this text, this code that you're seeing here in my terminal is being interpreted and rendered by the browser, and it is displaying it in this fashion. But what this means now is that we now have an HTTP web server running on port TCP 80 on my machine. And that means we should be able to scan it. And so I'm going to run my netstat, and you can see here local address. So this is a different IP address. This IP address is used when you are hosting a server of some sort. 0.0.0.0 is a special IP address which refers to any IP address that is on my device. And so you might have multiple different network adapters on your computer. Say, for example, you have a wired connection and a wireless connection. Each one of those adapters will have its own IP address. And so you can actually specify, do you want an application to listen for traffic, for data on one of those specific device IP addresses, like the network device IP address, or the other one, or any of them? And so the 0.0.0.0, this refers to any of them. And so if I have two different devices for network connectivity on my computer, and I get an incoming request from either one, what this is showing on netstat is that I have a Python 3 program listening on port 80 on all of my devices from any foreign address. So any connection externally coming to any of my connections on my computer, those are being listened to, and any data that comes in will be sent to my Python 3 program. And there's also a process ID, that's this PID. This is the process ID for this Python 3 program. If I come in here and I kill my Python 3 program and I run it again, and I run netstat again, you can see that I now have a different PID because this is a new process with a different process ID. And all of these connections timed out, and so now they disappeared. So the only thing in here is that I'm listening to port 80, and any traffic going to port 80 is being sent to Python 3. So let's run Nmap. I'm going to type in Nmap, and then by default, what will happen is if I run Nmap and I just specify the IP address that I want to scan, it will scan the top I believe it's 1,000 ports. You can see here, not shown 999 closed ports. It's only showing this one open port. You can see port 80 TCP open HTTP service. So we can see here that I scanned it, it's up. If I kill my server and then I run it again, you can see all 1,000 scanned ports are closed. I start the server back up. I run Nmap again, 99 closed ports, one open port, that is port TCP 80. And it's assuming it's an HTTP service because that's the common service that runs on port TCP 80. Now, this was very fast because I scanned a local IP address. Typically, it's going to be much slower if you're scanning over the internet. And so what you can do is you can use the -p option to specify which ports you want to scan. And so because I know it's on port 80, I can go here, I can specify -P80 and I can scan port 80. If I go in here and I type in 79, 79 is closed, and you can see instead of saying state open, it now says state closed. You can also specify a range. I can say, let me scan from port 1 to port 100. And it says, instead of saying 999 closed ports, it just says 99 closed ports. And TCP80 is the one that is still open. And this gives us a lot of flexibility so that we can save time if you have a general feeling of what the port number should be, or maybe like you don't want to scan 1,000 ports, you want to scan fewer ports. You can do that, and it will speed up your scan. Like I said, it's instantaneous right now because it's actually not going over the internet. I'm scanning my own computer. It's really fast. If there's a bad connection to a remote web server somewhere, it's going to take forever. And so just keep that in mind. A lot of times when you're doing these scans, it's best to invest a good amount of time into the actual commands of the scan itself. Make sure you get it correct, and then let it run and go get a coffee and come back or something, because sometimes it can take a while. It means that you really want to make sure you get the command right, because if you did the wrong scan and you wait a long time to come back, it's just, it doesn't feel good. It feels like a waste of time. So make sure you get your commands right. So now that we've scanned port 80, what I'm going to do is I'm going to show that I can actually go in here and I can change the port that I'm running on. And normally HTTP port 80 is for TCP port 80 is for HTTP traffic. I'm going to say I'm going to put this on port 123. And so now I'm starting my server on port 123. And if I try to scan my ports 1 through 100, I won't get anything. I scan it, all 100 scan ports are not available. But let's just say I scan ports 100 to 200. Now you can see there is port 123 TCP open, and it thinks that it is the NTP service because typically that's the port that NTP operates on. But we were tricky here and we put an HTTP server on port 123. And so Nmap is actually giving you wrong data here. And so what you might actually want to do is do a service scan. And you can do that using the -S and then uppercase V option. And what that will do is it will try to identify like the version number, like the actual software that is running. And you can see that when I do that, we get A, another field here for version, but B, the service is correct now. So when we just did a plain scan, it just checked to see, is the port open, yes or no, and then it will display the service here that it's guessing based on the number alone. When we do -SV, Nmap will actually try to determine for sure what is this service that is running here. And you can actually see here that like our Python server is throwing these errors. It's like, whoa, what is this? It's actually got a lot of different requests from Nmap. 1, 2, 3, 4, 5, 6, 7, like a bunch of different requests. This is all part of Nmap's process. And you can actually see here, Nmap lower check, whatever this is. This is all part of Nmap's process for identifying the service that is running. And as you can see here, when it did that, it has determined this is actually an HTTP server, and it is the Python simple HTTP server. So Python 3.9.2 simple HTTP server 0.6. And it's probably getting this information from the HTTP headers in the responses that the server is sending back. And so that's how it's able to determine it. But this is very, very helpful for being able to identify what is actually running on these different ports. So next step I'm going to do is I'm going to now use a firewall to block that traffic. And so I'm going to use IP tables, and IP tables will require root permissions. And so I will use the sudo command to get root permissions when I run IP tables. And what I will do is dash uppercase A specifies to add a rule to the firewall. And um, I'm going to specify that here's my dport 123. Where should I drop? Okay, so what this is doing is it's dash A is adding a rule, and it is adding a rule to the input chain. So this is the incoming traffic for the TCP protocol, and the port 1, 2, and 3. Or sorry, not 1, 2, and 3, 123. And it is going to, with this dash J drop is specifying take any traffic coming in on TCP port 123 and drop it, ignore it. It will not get it into the mailbox. So I'm going to add this rule. It's going to ask me for my password. I add it to, I give my password. I can now check IP tables and confirm with the dash L option, and I need to be root again, so I'm going to type in sudo again. This dash uppercase L will actually show all my firewall rules in IP tables, and you can see here drop TCP traffic from anywhere to anywhere on port 123. All right, so now if I run my scan again, you will actually see that this now says state filtered. And that means that our traffic is not making it to the mailbox. Our traffic is being blocked. And that's what this filtered state means. Now we're able to accomplish this with the firewall here. It could be, this is a firewall running on our machine, but like I said before, it could be a firewall being run on a router, for example. And Nmap, like with that basic scan, will not be able to tell you that. You just know that something along the way is blocking my traffic. And what I'll do now is I will actually go back and remove that firewall rule with the dash D option. I can check here, the firewall rule is gone now. And then if I run my port scan again, we're going to switch from filtered back to open. So that's how you run a basic TCP scan, as well as a version scan, a service version scan. You're going to use the lowercase dash p option to specify the port or ports that you want to scan, and you're going to use the dash lowercase s uppercase v option to specify a service scan. Now, next step here is I want to actually go and try this out on a challenge within the National Cyber League gym. And so that's what I'm going to go do next. But first, I'm going to go and answer this one question that I was seeing in the chat. We have a question. My server has been stuck on the serving HTTP on 000 port 80 line. Yes, that is expected. Actually, if I go back here and I run this again, that's what it's doing. The server is running, and so this command will not return back to your cursor, because when it does, the server's no longer running. And so what I would recommend is, if you want to run the server and then do some other commands, do what I did where you have multiple different tabs. There are other commands where you can use something like nohup, N-O-H-U-P, as a program to like background your task, your command, so that you can continue using the command line while the server is running. Like that's probably the best bet for what you should do there. Because if you use Control C here to get your prompt back, you can see here that it's exiting the server. And so, yeah, if you're going to try this at home, make sure that you use different tab, or use a tool like nohup to background the process so that you can continue using the command line. All right, so I'm going to go to my history now, because I know that I had this open before. I had it closed, and for demonstration purposes, how the heck do you get to your history here? All right, no matter. I'll just go back to our website. As a warning, our website doesn't work so well on the very outdated version of that, like the really jank version of Firefox that you get on Kaliat. Like it looks kind of weird, but it should work on like normal web browsers. I'm going to go to our to the scanning challenges, and the prompt that we have here is to run a port scan on ports.city in the dot cloud, and we're being asked for the lowest TCP port, the second lowest TCP port, the third lowest TCP port, the lowest UDP port, and what software is being run on port 16080. So we have our work cut out for ourselves. So what I'll do first is I'm going to stop this terminal, this web server here, and I'm going to shrink my terminal so that you can see both at the same time. Okay, so now that we are here, I'm going to run Nmap -p, and because this question is asking for the lowest TCP ports, what I will do is I will actually start with specifically searching for, let's just say 1 to 500, because it doesn't make sense for me to start scanning the high number TCP ports. And for the record, let's see, max TCP port value. There is a maximum value. It's 65,535. So it's that's the maximum value. So it's a finite number. They don't go on forever. So I'm going to scan 1 through 500, and by default, Nmap will do a TCP scan, so I don't need to specify an option for a TCP scan. I do need to specify an option for a UDP scan for question 4, and I'll get into how to do that when we get there. But now that I have my port number, my port range specified, I need to specify which device I am scanning. And so I need to scan ports.city in the dot cloud. So ports.city in the dot cloud. Now, there's another option that you need to specify specifically because we are on the we're scanning a server that's on AWS, which is this -p lowercase n flag. Like AWS, like Amazon AWS is doing something funky to like prevent these scans from happening normally. So we'll just go in here and specify -pn like that and run our scan. And if you look at the guide, it will let you know that. This might take a little bit of time, so I'm going to go and answer a question in the chat while I let this run. And we have someone asking, how do we end the Python server? You can close the window. You can also do Control C. Control C is typically how you would kill a program in a command line, from the command line. Okay, so now we've got our ports here. We have 7, 13, and 37. And well, there's a spoiler here because that's listed as the answers. But if I just type them in here, 7, oops, sorry, typed in 3, 7, 13, and 37. Those are our lowest TCP ports. We realize that some of the scanning stuff can be pretty annoying. So as like a little bit of a pro tip, like it would be really mean of us to ask for like the lowest TCP port and then have like a port that's like, 50,000 or something like that. So like you can probably guess, to save yourself some time, like try going and prioritizing like the lower numbers first and work your way up. because there's no reason that you need to scan like those super high numbers from the get-go. Like if you try scanning the lower numbers and you're not getting what you need, then you can go for the higher numbers. All right, now we're being asked, what is the lowest open UDP port on the system? So we now need to use the dash lowercase s uppercase u option. This will specifically do a UDP scan. And what I'm also going to do is I'm actually going to drop this number down from 1 to 500 to 1 to 100, and the 1 to 10. And the reason for that is UDP scans are rough. So remember how I described earlier that UDP is a less reliable connection? UDP is considered fire and forget. TCP, what will happen with TCP is that if you send TCP packets, there is a system in TCP where if it is detected that your packet did not arrive, your mail did not arrive, the protocol will automatically identify that and resend your packet so that you can reach the server. UDP does not do that. UDP is fire forget. Your packet goes out over the internet, and if it doesn't reach the destination, you don't get informed that it didn't reach the destination. And so you can be in a situation where like any number of different things could happen on the way. Like a router on the way to the destination might have gone offline in the middle of you sending you doing your scan. It's also possible that like a solar flare happens and a bit gets flipped somewhere in data, and like now the IP address of the source of the destination is messed up, and so you don't get the response back. Like any number of different things could occur, and because of that, we typically don't do too many UDP scans as challenges. And if we do, we try to like make them as easy as possible. But keep in mind though that like, given those circumstances, if you run a UDP scan and it's not working, like you're not seeing any results, you might want to run another UDP scan, or run multiple UDP scans, just because like there could be some funkiness that is happening, like just as a fluke, right? Like just by circumstance, the data didn't go through. So that's my caveat with this. So I'm going to run this scan, and now it's telling me you requested a scan type that requires root privileges. So I'm going to go back. I'm going to type in sudo. That will give me root privileges. I need to type in my password. And then now it will run the scan. And you can see here that we have a bunch of ports that are open or filtered, and one port that is specifically open. So because UDP is this fire and forget protocol, like you might send data that made it to the server, and the server got your data and then just chose not to respond. And that will look the exact same as your mail never got there, right? So in this case with port 7, with this echo server, what happened is we sent UDP traffic to port 7 and we got a response back from the application. So we definitively know that there is something running on port 7 because it responded back to us. TCP can get this, with TCP scans, we didn't get these open or filtered all over the place, because when you establish a TCP connection, part of that process involves the server sending back a connection to you. And so you can actually see that happening. And that's why with the TCP scan, we were only getting these open entries here, or specifically the filtered or the closed entry. But with a UDP scan, like we can definitively know if something is open, but we don't definitively know that something is closed. You can assume here that it is closed because there's no application listening to it and sending data back for the purposes of this challenge. And so now I'll come in here, I'll type in 7, and we've completed that. And then our final challenge is specifically what software is being run on port 16080. And so we already discussed how to do a service scan. So it's Nmap dash SV for service scan. And then I'll do dash, I have to remember to do the dash, what was it? P, yeah, uppercase P, lowercase n. And I need to specify my port. So I'm going to specify port 16080. And our target is ports.city in the .cloud. Okay, so this might take a little bit of time because Nmap is actually going through and doing all those extra steps to identify what is running. And you can see here that the results came back in. Port 16080 TCP, it is open, it is running an HTTP service. That appears to be an Nginx 1.10.3 server, and that's a web server. And we can see here as well, it's even giving us information about the operating system. It realizes that it's a Linux system. And so to answer the question, what software is being run on this port, that would be this Nginx server, Nginx. I'll just type in the version number just for the heck of it. And now we're done. So that's how you run a TCP scan. That's how you run a UDP scan. That's how you run a service scan. Another caveat to all of this is that, like, be very mindful of where you are scanning from. A lot of this depends on you not getting blocked or having your traffic messed with by anything between you and your destination. And we've seen a lot of instances where like school networks will like block some traffic or it will redirect some traffic. A lot of like ISPs will specifically see like outgoing connections on specific ports and like redirect it. I think an example here that we have in the write-up is that like for some reason a lot of like port 25 mail traffic, when it goes out, it will like get redirected to, if you're using Verizon, it gets redirected to like the Verizon mailbox that you might have with your internet. Like that stuff happens, and you need to be very cognizant of like any funkiness with that. So what I'd recommend is, like, if you want to be 100% certain that like there's no funkiness going around, like you need to go and there's a lot of different services that will give you free cloud hosting. So definitely check out DigitalOcean. I don't know if they still do promos, but they do a lot of things where it's like you get like a free $100 credit. And so you just sign up with a new account, you get a free credit. Got to be a little bit careful with some of the scanning stuff because they will block your account if you're scanning. AWS, the same thing. You can create an account and get a free credit. If you do it too much, they will detect that and block your account. Like I've seen it happen. It's happened to me before. So like, just don't go crazy with it. Or, you know, if you have like a VPN connection, that like a VPN service that you know will not filter and block your traffic, you can send all of your traffic through your VPN, and that will help mitigate some of this funkiness. But, you know, got to make sure that the problem is, like, it's hard to diagnose the problem. Is the problem your Nmap scan, or is the problem like something to do with your connectivity to the destination? And just keep that in mind, is that like if you're 100% certain that your Nmap scan is correct, then see if there might be an issue with your connectivity there. It looks like Alexis is asking, how can we spot the funkiness if it does occur? Typically with this is that we'll like ask for like, what are the like lowest ports here as an example, right? For the lowest, the second lowest, and the third lowest. And the numbers don't, like, if you do a scan and you only find two things, and you do a lot of scanning and you still only find two things, and we're asking for three, it's like, okay, well, what happened to that third one? It could be that like your ISP might like redirect your mail traffic, your port 25 mail traffic, and you'll get an extra port in your result. And when you type in the port 25, you'll get an incorrect answer. And what I would recommend is try connecting to the actual service itself and see how it identifies itself. Typically, if like Verizon is like redirecting your port 25 traffic, you'll get directed to like a Verizon portal. And so you can diagnose that. Also double check like if I if you're connecting to that port and you're being redirected, you might see in Wireshark that the IP address that you think that you're supposed to be connecting to, let me just do a ping here. I'm going to ping ports.city in the cloud. This is the IP address of ports.city in the cloud. If you run an Nmap scan and you look at Wireshark and for some reason your traffic is going to a different IP address, that's a sign that something's funky. So, all right. That's all I wanted to show you all today. I'm going to go and answer some questions, but at the same time, I'm going to put up a poll here for what topic we should cover next. Actually, a second poll here. So one is we're interested in whether or not you'd all be interested in discussing DNS basics, Linux command line basics, and then I have a second poll here for whether people are interested in videos about creating a cyber startup. Like, do people have an interest in entrepreneurship? Have you considered maybe I got this cool idea for a company, like I want to learn what it's like creating a startup? Let us know. But in the meantime, I will go and answer some questions here. So Tally's asking, when should you close open ports and how do you close them? So I showed how you might close them in Linux with IP tables. And let me pull that up on my history, IP tables. This is the command to drop traffic for a specific port. Generally, I would say that like firewalls are like not particularly helpful as they're not a reliable line of defense. So don't rely on IP tables for the most part to protect you. I don't think that having open ports is a problem. Typically, if you want to close them, there's two ways. You have the IP, you have a firewall, and in Linux, this is IP tables. On Windows, there's like a whole, I don't even know how to do it on Windows. You got to go to the control panel. Every version of Windows moved where you do it in the control panel, but you can specifically go and say, hey, block any traffic to this port. So that's with the firewall route. The best way to close the port is to run something like netstat and to see what open ports are even on my computer, and then you go and you kill the programs. And so you'll open Task Manager. In Linux, the Task Manager is called it's PS, and I do like a PS aux. And so what I could do as an example is I will start the Python server here. So I've got the Python. Can I pull this out? Let me just open a new window here. So I have my Python server here on port 123, and if I run netstat plant, typed in the wrong password. If I go to netstat plant, you can see here that there is a application listening on port 123, and here's the process ID number. And so what I can do is I can type in sudo kill -9, and this is a force kill on the process ID, and that is process 3085. And now you can see that this process got killed, but if I run netstat again, you can see that whereas before there was something listen on port 123, that's not here anymore. It's no longer listening on port 123. So that's how you go about doing it in Linux. The process is slightly different on Windows. The concept is the same. You just don't have netstat and you don't have IP tables on Windows. There are different equivalents. You have the Task Manager on Windows, and you have the Windows Firewall on Mac OS. It's a different set of things. I don't even know if there is a firewall GUI on Mac. I know there is IP tables on Mac, but the concept is the same. Kill the service that is running on that port, and alternatively block the port with the firewall. But I wouldn't concern yourself too much with like specifically proactively closing ports. If you notice that something's running that you don't want running, it makes sense to close it. But for this is mainly an issue for enterprise environments of like, oh, this service should not be running. I need to block it with the firewall, or I need to stop the service on the machine. Like the machine should not be running a web server, or maybe the machine is running SSH. SSH is used for remote login administration, and maybe someone shouldn't be remotely connecting into that machine. That's when you'd want to close the port. But for general like personal use, it's typically not an issue. Bruce asked, would you suggest T3 for internet scans in NCL? So T3 is specifically like the speed at which Nmap is scanning. I typically don't mess with the speed settings, so I can't really comment on it. I think if you're being like pretty smart about what IP port what port ranges you're scanning, you don't need to adjust the speed settings with Nmap. Like I was scanning, if you're scanning like 1,000 ports, that shouldn't be too bad. If you're trying to scan like 60,000 ports, yeah. But I would recommend actually adjusting the port range rather than the port scan speed as your solution to that if it's taking too long, because the more ports that you're scanning, the higher the risk is that like something goes wrong and you miss what's actually important. Like a packet gets dropped, for example. If you're scanning a shorter range, the odds are lower that like you have a dropped packet, and it means that it's going to run faster, and so you can run multiple different scans to be sure if something got dropped. All right. Okay, we have a P. Ellis asking, can you show us how to use Nmap? Nmap is a graphical interface for Nmap. I can show that in a future one. I'll add that as a poll option for the next one. I think people already voted for most of the poll options for today. But it's basically the exact same thing. There's actually even like a field where you can see the equivalent Nmap command in Nmap. I can show that off, but it's going to be a very similar process. So I'll add that as a poll option in the next episode. And Tom is asking, can you block the service instead of the port? Would that be more complete? Yes, it will. There's no guarantees with the firewall. So if you, let me clarify that. There are no guarantees that the firewall will continue blocking the port. If, for example, you disable the firewall, right? Like if you disable the firewall, it's no longer blocking it. As long as the firewall is active, it will block the port, right? But let's just say, as an example, if I use IP tables, by default, IP tables won't save the firewall between reboots. And so if I reboot my computer and I thought I was blocking a port, all of a sudden I'm not blocking the port anymore. So the best way to actually stop this, to like actually be safe and not have that like service be reachable, is to disable the service. Make sure that it doesn't turn on by default on startup, and make sure that you kill the process if it's currently running. All right. Well, thank you all for joining us today. As a final reminder, if you want to practice this stuff, you can sign up right now for the National Cyber League. There's a little green button on Crowdcast. You can click on that to register for NCL. The gym is open. You will get immediate access right now. If you're watching this after our live stream, you can register for NCL by going to you can either go to the nationalcyberleague.org website and then click on the button there for registration, or you can go to cyberskyline.com/events/NCL. Either way, you will get to the registration page, and we look forward to having you in the NCL season. But with that, I appreciate you all for joining us today, and have a great rest of your week, and take care. Till the next one, see you.